Okay, thank you very much. Well, thank you, first of all, to Gennaro for organizing this. So I'm very happy to be here. First of all, my affiliation here is different from the one you will see on the program. And that's because I am in this PhD partner workshop, but yesterday I had my Viva, so now I'm officially just a postdoc. Thank you. As my supervisor know. Yeah, bold move from my side. So now I'm postdoc at Scuola Superiore Sant'Anna in Pisa. And today I'm going to present you a part of my thesis, which is the Climate-Demography Nexus in Italy, an assessment of the distributional impacts through an ecological SFC-IO model. So let's get started, and let's start with my research question. Well, my whole thesis was about investigating the impact of climate change on the income distribution in Italy. And I focus on Italy not only because it's a large developed country, but also because it's highly impacted by climate change, at least above the average of the rest of developed countries. And I mean, there are different channels of transmission to which the climate change have an impact on the economy. And normally they are divided into transition and physical risks. And in my thesis, I focused on physical risks. Among physical risks, there are acute and chronic risks, where acute are basically impacts from single and somewhat unpredictable extreme events, while chronic risks are the ones that stem from the building up of the change in the climate. And in this work, I focus on the demographic channels, which are the channels that directly impact the population composition and growth rates. So this study specifically looks into the changes of mortality and immigration that stem from climate change, and looks at the impact that they have on the economy, on the macroeconomy, and the distribution using an SFC model. So, as I said before, I focus on Italy because it's an ideal case study, because it faces about the average warming, and that's due to the so-called Mediterranean hotspot phenomenon. But also because specifically it has an important role in Mediterranean migration flows. So in terms of immigration, it's an interesting country to study. And also because it's experiencing rapid population aging, and also not so much potentially actual long-term decline of population. So to investigate this, I developed an ecological SFC model, discrete time, calibrating on 2019, which means that this is actually a theoretically developed model, which I then calibrating using real data from some variable, and I use the structure of the model to constrain some variables and some parameters, while some equations have been macroeconometrically estimated. I won't go into this presentation, but this is the right crowd to say that if you have questions and curiosity, I'm happy to discuss about it in the upcoming days. So, about mortality and immigration specifically, there are actually in all the integrators in the model, so in a lot of ecological or environmental macro literature, they have population projections, so they take into account somewhat about mortality and or immigrations. However, there are just a couple of studies that try to look at the distributive effects of this phenomenon, and they're typically done through spatial equilibrium models, so very different class of models. While here I'm using SFC macroeconomic models to do that. So let's talk a bit about the model I developed. First of all, for marketing reason, I came up with a catch name, which is Titanic. This is the acronym, but again, it's marketing to promote myself in that. What are the main features of the model? The model has three feature classes, which is where distribution happens. And then I'm going to explain to you how I calibrated this. There's an input-output models with 26 sectors, which stands for Nexus base, a financial sector, and 4 financial assets among with that in which households can invest, which are deposits, cash, bills, and equity. It's an open economy model. There's a government providing pensions, government expenditures, which grows exogenously in per capita terms. Demographic effects also government expenses. And then, of course, there is a demographic model, which I'm going to detail a bit later, but it has 3 different age groups.
Yes, government grow in per capita terms, but depending on population or growth.
The government expenditures in per capita term growth rate is constant, which means that if the population decline, it grows less. Okay, so households. As I said before, 3 subject classes: workers, managers, and capitalists. Workers mostly earn wages, receive unemployment benefits, and only invest in savings and deposits. In cash and deposits, sorry. Managers earn wages, and their wages are higher than the workers' one, and I'm going to show you the calibration of that. But also they receive a share of profits, while capitalists receive most of the profits. The consumption function is a pretty standard, would say, consumption function in the SFC literature. But what about the calibration? Well, I use the survey on household income and welfare on the Bank of Italy, which is a very detailed micro dataset, which includes information about the sector of employment and the job category of employment of the individuals of the household of the survey. So what I did, basically, I took the survey and I was able to assign to the class of manager the households who had at least one person classified as manager in the job type in the survey in the first semester. So those were identified as manager. Then I took the top 1% as capitalists, which is a strong assumption, but I mimicked the Eurogreen integrated assessment model in that. And that's sort of circumvent the difficulty to extract the true capitalism from autonomous workers in this split. And then the rest were workers. So using this survey, I was able to compute the shares of the aggregate variables that goes into the 3 social classes and assign those to the 3 social classes. So this is the calibration of the social classes in a nutshell. And this is the results, basically. These are the 3 social classes, their income sources. As you see, managers also earn profits, but their share is fairly low compared to capitalists. They receive pensions, the amount of benefits changes comparing from workers to managers, and there's no going to capitalists. And yeah, this stems directly from the procedure I applied before. Now, how does labor market works? First of all, this is a vector, but since the model is a demand-driven SFC model, the demand of workers at sector level depends on the output, on the labor productivity, and then there is a partial adjustment mechanism to avoid one-to-one adjustment in employment to output. And the wages, you can see the equation, but I'm going to describe it to you. So the growth rate of wages depends on the employment level, on the inflation rates, and the growth rate of productivity, which is, again, I would say a fairly standard way of model wages. Of course, one could debate about that. But this is for workers. For managers, the story is a bit different. First of all, the employment follows a similar trend to the workers' one. It's a bit more complex, but very, very briefly, basically, the employment of managers follows the workers' one, but the starting point is lower because, of course, their unemployment level is structurally lower. What's different is their salary, because the salary is calculated by multiplying the workers' wages by a term, which is the differential between managerial and workers' salary, which is again calibrated using the survey I mentioned before. And then there is a bonus component, which captures the performance, sort of performance-based remuneration of managers, which is activated if the growth rate of profits is higher than the growth rate of profits in the base period, so in the starting period. So in this way, I capture also this financialization effect. Then in the model, there is also a mechanism that transmits the bonus into a permanent increase of the base differential, but I'm not going into that detail here, but happy to talk about it if you have needs. Now, what about demographics? Average groups, as I mentioned before, and this is, they are divided from the age, retired individual, which is the number of pensions receivers from the Italian national security scheme, and the working age individuals is basically this. The age groups are homogeneous by class, so the class has the same age composition. And this is how their evolution is, works with the equations in the model, but these are fairly standard demographic equations. What about the productive sector? I said before, there is an input-output model, so I computed the 26, I had 26 final sectors in the model, which are based from X to base, but I had to make the model talk with the EU-CLAMS database, because capital and investments are based on the EU-CLAMS database. So basically, I condensed X to base 163 original sectors into 26. While the capacity utilization of this sector as a data source from the European Commission survey. Investment are set at sector level, meaning that each sector decides its amount of investment based on its capacity utilization. And the investment function is fairly simple because it simply depends on the utilization rate in the previous period, which still contains the accelerator principle. And this is one of the equations which has been econometrically estimated. Then it's fairly standard production at Leontief, and there's a markup over unit cost pricing rule for firms. Final model structure slide. So the model has an ecological module that maps the exchange between the economy and the ecosystem, and most importantly, it models the evolution of Italian temperatures according to the shared socioeconomic pathway 3.7. Now, how do I use the model? Basically, the model runs a baseline scenario in which the economy is in a steady state growth, in which there is no mitigation or structural change, and importantly, in which the climate change has no effect on the economy. Of course, this is really unrealistic, but this is the strategy I used to isolate the effect of physical risks, and in this case, demographic effect. Because then the baseline is confronted with a series of simulation in which one different channel of transmission through which the economy, the climate change impacts the economy is activated. So in this case, one in which mortality increases, one in which immigration changes, and one in which we have. And in this case, you can basically just isolate the effect of physical risks without policy changes and without mitigation policies, let's say, canceling out the. One of them would like to also include that and see the difference. And I guess that would be another work that it's really would be nice to do. But this is what I'm going to show you now. So what about the demographic effects? I just talked about. So first of all, I said before that it's mortality and immigration that I'm studying. And regarding mortality, well, the literature tells us that mortality and temperatures have a sort of a U-shaped correlation. So mortality increases when temperatures are really low or really high. So the effect of an increase in temperature depends really on the starting point of the country considered. But once again, the literature tells us that in South Europe, so in Italy as well, the effect is false. So we expect an increase in it. How this is included in the model? So in Titanic, I introduced a linear relationship between mortality and temperatures using the estimate from this meta-analysis, which aggregates the results of multiple studies. And from that, I basically have the M1 coefficient there. And then these results is weighted with age group specific risk coefficients, which I determined using using study which identifies what you would expect, so that all people are more affected, and things. So the death rate in the demographic equation simply increases and temperature increase, and the effect is age group specific. So it's there is also age group specific component. Now, migration is more tricky because global temperatures are projected to increase migration from hot region towards Europe. But the migratory responses are, of course, nonlinear, and crucially, they depend on the specific policy on of start of origin and destination. So it's more difficult to model that. I did that using this study, which I found it very nice because they estimated the responsiveness of asylum application into the European Union to temperatures in crop growing season in a series of. So basically, I took the functional form, which is a quadratic functional form that they estimated, and assumed that the starting effect was none. And then I multiplied that to the immigration rate, age specific, of the immigrants from outside the European Union and outside the US and Australia, so other developed. Basically, here the assumption is that the trend and the pace at which the immigration of all climate migrants, not just asylum application, follow the same path of the asylum application, which is, of course, a simplification. I would say it's a fair one, but we could debate about that. Then you cannot see, but the climate migrants are assumed to be part of the workers class. Again, a simplification, but it is true that climate migrants are typically overrepresented in the lower tail of the income distribution. So this is the result in terms of population composition. This row here is the baseline in population composition. Up here, we have the population composition of climate migrants. While in there, we have the three simulations. So climate migration, mortality damages, and both. And in both cases, the number of working age people increases, while the number of retired people decreases. The size is different, but the direction, let's say, is the same. These are the results in terms of overall calculation. Here, the graphs should be read as difference with respect to the baseline in percentage terms. So with this calibration, you can see the light blue line is climate migration, so overall population increase. The green line is a combined effect, while the yellow line is the increased mortality. So we have an overall decline of population with increased mortality, and the combined effect is still a decline in population with respect to the baseline, but a smaller one. And the other three graphs are just to show, as I mentioned before, that the population composition of the three subclasses are affected in different ways by the different channels. And these are the results in terms of more economic aggregate values. So as one would expect, the real GDP correlated population, because a higher number of people means high demand, so higher level of real GDP, and on the opposite side, decrease if we have less people. So this is that it follows the population graph. In per capita terms, the effects are smaller and also importantly reversed, which means that per capita GDP by a small number by the end of the century. So the effect is fairly small, but there is a decline in per capita real GDP, which is the top right graph, when there's climate migration, while an increase when there is mortality damage and the combined. Now here, three forces are at play. The main three forces, I would say. One is the direct effect of demand, which is correlated with population, as I said before. Another one is the labor market effect, so a higher number of working people without changing the level of demand, let's say, means a higher level of unemployment or lower level of unemployment. So the labor market conditions changes, and that also have an effect on wages. And then the third one is the population composition effect, which means that the different composition of the population has a different implies a different income source composition of the three social classes, which can also increase or decrease demand, and have another channel of it. These two bottom graphs represents the effects on unemployment on the two social classes. Once again, not very much strong effects, but still, in all cases, workers' unemployment are higher. But importantly, when there are mortality damages, the effect is somewhat smoothed, which means that initially the demand decrease effect due to the decrease of population cause an increase in unemployment. But then the effect on the labor market, composition somewhat kicks in and becomes more powerful. So there is a sort of stabilization, which with a small tendency to decline. Since the effect of the population changes are also class specific, the effect of the others is different. So there is a decline of their unemployment, which is also reflected in their disposable income. Last part, which is the real per capita disposable income by different classes. So the red is the capitalists, the light blue is the managers, and the green is the workers. And so when there are mortality damages, we can see that actually the workers' real disposable income is the better of one. And this is mostly due to the labor market channel, which favors their real wages, and this goes against the profit share. And there's also another effect, which is through the age group composition, has the change in the income composition. The real disposable income of capitalists is a bit more effective because they receive less pensions, but they're not compensated with higher subsidies in the working. So basically, what happens in this specification of the model is that diminishing the number of elderly people, the capitalists receive less from the overall wealth. But the main effect still is driven by the labor market channel. Things are different when we look at Climate-Demography. In that case, the labor market channel goes against workers, so they decline in their disposable income while capitalists and managers grow. Again, managers have this link of their salaries with the profits, so that's why they have very disposable income growth. And in the combined effect, there is a sort of a sum of the two channels that ends up with managers being the better classes. What's interesting to notice is that when we consider one specific channel at a time, the effects are different, and their cumulative effects give results which you can see they are sort of the sum of the two, but it's not exactly the same of the individual ones. So to conclude, and this is my last slide, mortality and migration have a sizable effect on GDP, although the size is not that huge. And of course, the results vary if per capita values are considered. The main channel that are behind these effects are changes in labor market structure, in the real wages and real profits as a consequence, in the changes in the age composition, and the underlying change in demand. A mortality increase tends to favor workers through the labor market and the age composition channel, while crime and migration tend to favor capitalists. I have to say that these results also stem from one assumption, which is the homogeneity of the distribution of the industrial sector of employment of native people and immigrants, which is exactly what I would like to get inside a bit more in detail before trying to actually extract a final version of this paper. Because I have industrial sectors, but as of now, the distribution of the employment of workers, native workers and immigrants is the same. Of course, in reality, that's not the case. And that could either exacerbate or dampen the direction of the results of the immigration channel. Yeah, when both channels are activated, there's a better class, but that's already shown before. Yeah, that was it. Sorry if I went a bit fast. Thank you very much.
Thank you. Thank you for the presentation. So I have read the paper, and the thing is a really nice paper, first of all. And I have some comments, maybe about something and some questions. So the first comment or question is about the assumption about the stimulus